Jones. I work for Redgate Software. This is Redgate. We do lots of different stuff on there. We, just in terms of the AI thing, let me just put this up here. So we have built SQL Prompt for many years. Oh, that was fantastic. Didn't want that to happen. That's my house, by the way. So there we go. All right. SQL Prompt has done IntelliSense for many years. Some of you may have used it, some of you may have not used it, but we built it as an add-in to make life easier. Earlier this year, we've been doing a lot of research on AI, so we actually added an AI assistant to SQL Prompt. So you can do things like natural language query here. So I'm going to say, what query do I need? And it'll write the code for me. We actually added a tuner in there, so it could tune queries. So you don't need to call Martin anymore. You could just tune query without calling him. And it's kind of cool because the responses will tell you a little bit about what the problems it sees and why it would make a change. And then, as Hamish said, right, for generating data, this isn't generating data, but it's generating schema. So you can describe a little bit about what you're trying to do. So if you're trying to do insurance, you could certainly have it help set this up and then use either a ChatGPT type LLM or even something from Python from Faker or CKit. I thought it was Scikit. Isn't it science?
I'm a Kiwi, mate.
All right. But then you can populate data there. So we have this in EAP. So if you want to, be aware, right, all the metadata that SQL Prompt uses to do IntelliSense is going to come back to us from your system in order to populate the generative AI. Right now, we don't use your data to train things, but it does transit a network. So if you use this at work, please make sure your company is okay with that data policy. But in any case, that's out there. All right, so I'm not going to talk about AI. That wasn't really my thing, and actually I want to make sure I do. We want to duplicate, so things are just duplicated. All right, I have a presentation here. I am here to talk about DevOps. We don't want to use presenter view. All right, so I do a lot of work with DevOps stuff with a lot of clients. I do a lot of architecture work with customers. I do a lot of just kind of consulting in general to people that are trying to figure out how to better build and manage database software. Okay, so this presentation is kind of about DevOps a little bit. I've been doing this stuff a long time. I'm old now. I do run SQL Server Central still, and then as part of my job for Redgate, I do some advocacy with stuff like this and events, as well as a lot of architecture work with customers. My contact information is here, and it'll be at the end as well if you want to find me. So I start this talk a little bit by just talking a little bit about DevOps. Some of you may have an idea what it is, some of you may not. But what I like to try to do is to kind of set the stage a little bit. DevOps isn't really tell you how to build software. It tells you things you want to accomplish when you were building software in order to be better. So there's these three principles here: systems thinking, feedback loops, and then learning and experimentation that describe what we want to do. It doesn't really tell you how to do this stuff, but the goal is with systems thinking, I want to flow work through the system as quickly as possible. So the time I think my work is done, right? I'm sure you all have written code and you're like, it's perfect, it's amazing. From that point in time, how quickly can I get that to production? Has to go through QA, has to be tested, right? It has to be checked into version control. All this stuff has to happen. But how quickly can I flow work to my clients? Feedback loops are just what they say, but we want to amplify those and have more and more feedback. So this isn't does it compile or not, which is admittedly a very low bar. Still a bar, but a low bar. But does it, solve the problem we expect? Are customers using it? Does it work efficiently on resources? All the things we may care about in the database world apply here. Okay, certainly they apply in software as well. But the other thing we think about with feedback loops is it easy to deploy? Right? Can the DBAs actually deploy this in operational? Can it be tested well? All those types of things that we want to do to make better software should be part of our feedback loops from all throughout our system. And then lastly, we want to try new things. I think most of us in technology like to think that we love to try new things, but at work, a lot of us are not good at that. We lean on our experience and we don't want to change the way we've written code. And I find it really hard to get teams to shift and adopt new patterns. That's what we have to do if we want to build better software. I need the senior people to mentor the junior people. We all have to learn how to write better software. We have to take advantage of new features in the language new features and platforms, we have to be better across time. This culture thing is the hardest thing I find with customers. The technology is really easy, but trying to get this 22 people in this room to all write code the same way is incredibly difficult, right? Even with ChatGPT. So that's an important thing. There's a few books I've listed here that kind of describe what we're trying to do. Has anybody here read The Phoenix Project? A few of you? It's a really easy read. It's a short book. It's written about technology. So it kind of exaggerates and emphasizes the silly things we can do in technology, the problems that we have in building software. This is actually based on the other book, The Goal, which is really about manufacturing. And it's about the theory of constraints and bottlenecks. And it talks about a factory where we have trouble getting, products built, assembled, and pushed out. That's what we do in software. Right? A bunch of us write code. We have to assemble it together. We should test it. Right? It should be polished. It should be painted. Everything should be great. It should get to the customer quickly. Okay? I highly recommend both these books. Phoenix Project is really short. Most of you probably read it in a day or two. The Goal is a little bit longer, but it's a much better book. All right. Quicker way of saying all that comes from this quote from Donovan Brown. So Donovan Brown worked at Microsoft for many years. He kind of did my job, but for Microsoft, advocate or evangelist. And as he was trying to explain DevOps to a lot of customers, he came up with this saying. And at its heart, what this says is DevOps is a continuous delivery of value to end users. That's what it is. And when I tell technologists, they're like, of course it is, except most of you think your job is to close tickets and solve problems and make your boss happy and other things. Your job isn't done until that code gets to production. Right? So the goal is I have to find ways to work with the entire team of people to get that code to production. Donovan would actually say your job isn't done until that code is ejected from production and replaced with something else. But the whole goal here is no matter what framework, language, teams, people, departments, no matter what we do, we're trying to get value to our customers. And when we do that, that means we have to work together, right? Which is something many of us are not very good at. Some of us are better than others, but in general, across teams, across different departments, across different jobs, we're not good at working together. So the goal is to try to be better there. In practice, we talk about a lot of these things here that kind of are more in line with what we're trying to do. I won't spend a lot of time on this because I want to show you how this would work, I think of it. So for on the screen, it's just kind of a modern software development pipeline. So I don't know, how many of you are developers here? You write code? How many of you are production, DBAs, operations? How many of you aren't going to answer any questions?
In the previous role, but currently I'm.
You could just raise your hand for everything. So for most C# or Java developers, right, they know how to write code. They stick it in Git these days, or some version control system. There's usually some automation in place that checks your code to make sure you haven't broken anything. We would then either tell you you broke something, or we would publish out an artifact. So an exe, a DLL, a module, a jar file, whatever thing comes out of a compilation. And then typically what we do is we use some sort of server process to deploy that to our clients. It could be deployed to app stores and end up on your mobile phone, could go to a server, could go to a desktop, whatever it is. We have kind of an automated process. And in general, after we've written code here, nobody is really typing anything other than pressing buttons to say go at this point. Right? So it's a fairly typical software development process. If I change this a little bit around and say databases, I've shown multiple databases here. It's not really germane whether there's one or many, whether we're shared or separate. It doesn't really matter. But what I find is most database developers don't use version control. Okay? A lot of that is tooling. Tooling really is poor for databases. Most of us don't have CI in any place whatsoever. Instead, what we typically do is we call Hamish and we email him scripts. We trust Hamish to deploy everything to QA. And then if he finds a bug, we assume Hamish will fix it. And then when we deploy to UAT or production, we hope Hamish remembers to fix the same bug again. But if he doesn't, he'll probably fix it on the way.
Yeah, probably.
But we're dependent on a human here quite often to do things. Connect to the right machine, have the right credentials, include all the scripts and run them in the right order, all the things that we're trying to do. And we've worked this way for, well, I've done this for 30 years, right? 30, 40 years people have been doing this. But it's not a very reliable way. And these days, we don't have a lot of tolerance for people making mistakes. So we want to be better. We want to get more like application developers. So what I want to kind of show you is how we might adapt some of the things software developers do really, really well to databases. Okay. For me, what I would say the foundation is really version control, because without versioning, I don't have a way in a team to kind of keep track of what work is being done and decide what I've evaluated, what I've tested, and what I haven't done. Right? I don't have a lot of rules if you work for me, but version control is one of them. If you don't want to version your code, then you have to go find another job. And I don't have a better way of saying it, but that's just the way I would look at the world. I don't control your organizations. You may feel differently, but that's how I view the world. What I want to do, as much as I can, I want to treat database code like application code and follow the same types of patterns. And I want to use the same tools that application developers do. So if they use Git, I use Git. They use TFS, I use TFS. Okay. I want to do things as much as possible. I do think the database should have its own repository. I think it's a first-class citizen, just like any application. I know I see customers sometimes where they have a web app and a mobile app and a server app all in one repository, and we get collisions and difficulties sometimes in compiling stuff or versioning. It's a lot easier when those are separate repositories and we can work independently. Right? We still may have to pull in packages from other places, but I think the database should be its separate repository. The last thing I would really say here is that in C# world or in Java world, a lot of times we branch code to make changes. We may hold those branches for days or maybe weeks. At Redgate, we only allow developers to hold branches for a week. And at like 4 days, people start getting upset. They're like, you got to rebase or merge or something, because we got to know what's changing. In the database world, when I see people go beyond like 2 days, it's really dangerous, because people are making all sorts of assumptions on what the database looks like. And if you're not communicating back what's happening, it's really dangerous. So I'm all for branching. Just be super careful with database code, because other people are expecting the database to look a certain way. If you're not letting them know what changes are coming, we have problems. All right, how do we do this? So the goal really is to just get code into text. It sounds simple, but database code and tooling is fundamentally different from C# or Java or other application code. Because for those systems, we save files as text, and then we call a compiler to compile the code. In the database world, we don't do that. We don't have a compiler. All we can do is submit the code to a server, which compiles it, and it gives us nothing back except a little message that said, this command completed successfully. I don't get a binary file back in any way that I can manage, right? Which is also why, for most of us, we never save that code. Now, I could teach you all to do that. It takes about 3 weeks to teach somebody, even you. It takes about 3 weeks of me yelling at you every single day to save your code. But there are better ways to do it. Really, you need some sort of tooling. Now, SQL Server has SMO libraries that can do automation. Oracle has something similar. There are other ways to do this, but really you need some sort of tool, okay? Because the goal is, I want to get this code somewhere else. So let me do some of that. I want to see, hopefully my demo will go quickly and my things work fast. All right. What I want to show you is that's not what I wanted. Let's come back here. I've got these databases right here, okay? So I want to write code here. This is where I want to type as a developer. And I want to have that code go to all 5 of these, or the other 4 databases without me doing anything else. Okay. I don't know if I have enough time to get to all of them, but that's the goal. So is anybody a rugby fan here?
Rugby? You're in the wrong city, man.
Football?
Yeah, I don't know.
No. I have both those things covered.
Go red.
All right. So I've created a couple objects. I created a table. Fantastic. And I added a piece of data in here. Okay. Just to show you that I don't have anything up my sleeve here. I'm in a different database here. I don't have that table and I don't have that data. All right. Believe me? Okay. So what I want to do is capture this code and somehow get it into text. So I'm going to use a tool to do this. It's not really relevant how this works. I'm actually going to, where is my other thing here? Sorry, I can't remember stuff. I actually am trying to track my work like a proper software developer. And so 255 is my demo. So we'll say brief live demo. Fantastic, right? There's my table. There's my data that I've inserted. Okay. I pick both of these things. What did I do here? Let's try this again. Should have a little checkbox somewhere. I don't think I updated anything. Here. Well, this is not going to go well if I don't see my thing. Let's close this and open this. You're bad luck, Martin. This was working earlier. You weren't here. I have a backup. This doesn't work. Let me see. Fantastic. No, there's something in here. All right. I have a better way of doing it. We'll save this actually. What I actually want to do this without breaking something. That's not where it is. Hold on. Make a new table. Luckily, there's multiple ways to skin a cat here.
You should pick the wrong footy.
Yeah, maybe. Put that in there. Where's that code? Grab some code. That's weird. I wonder if it's because I'm in 19. All right. 18. That's very weird. All right. Do this. I have code there. So
Right, gives everyone a chance to get more pizza.
very strange. If that works, I'll just commit that instead. Ah, love it when demos fail, live demos. All right. I'll play with this while let's see if this works, and we'll try something else while it's going. All right, so get. So what I just did there is I kind of did this manually because I just want to kick this thing off and have it run, even though I don't see changes there. Let's see. I'm gonna close that for a second because I think it is. I think Management Studio is acting up, which it does at times. All right. I did that manually. But what I actually did was I pushed some code up here into this repository. Okay. In this case,
Sorry, that's me.
I changed the file. I added this file there. That's so weird, Kelly.
Just me, or can I hear an echo? Echo.
I'll create a pull request and
So it's just, it's hard to see from the back. So I can see the screen up there. I'm sorry.
okay, no worries. So I just put some code in there and I committed it, and so it's just live there. I just wanted to get that moving. Just out of curiosity, I'm just curious if this will show up here.
No, both ends of the room can see when it doesn't work.
Okay, good. Yeah. Okay. The management studio is acting up at times. Let's let that run. In any case, I put code in a database, right? So essentially, I did this process of writing code, saving it to a text file, and committing it manually. Okay. Once I've committed code there, let's see, and that's there. Send this one in a minute. Once I've committed code, I've written code, what I really want to do is evaluate whether I did a good job writing that code. Right? The whole reason that we do CI is that for most of my career, we've often written code, had problems, and then we go back to a developer and the developer says, well, it works on my machine, but it doesn't work on your machine. And then we struggle to figure that out. Okay. Sometimes that's because we've changed configuration. Sometimes it's because we have different libraries or versions of things installed. So the goal is with CI is I want to make sure that I independently validate and verify code somewhere else. Not on your machine, not on any development machine, but some server machine elsewhere. Because that increases the chance that I think this code will run on the ultimate production system somewhere, right? Whether that's a laptop, a server, a cloud, mobile, whatever it is. Application developers are really good at doing this, been doing it for years. In the database world, we follow their process for the most part, except we don't have a compiler, right? So we need a database platform to run CI. The other challenge is for C# and Java and other languages. I take a whole bunch of files and I send them at the compiler, and the compiler sorts out what happens. Okay? In the database world, I can't do that. Right? I can't load 8 files at once and send it to the SQL compiler. I have to send them in order. Right? I can't create indexes without tables or views without tables. There are certain dependencies that happen. So essentially, in order to compile my code, I need to pull my code from version control. I need to order it according to the rules of SQL. Okay? And then I have to run this on a database somewhere, ultimate. Okay? Evaluate the results, do all that stuff. And then I should test it. I'm a big proponent of testing, and Hamish is a big proponent of testing. I should test this code. And then whatever I've compiled and tested, I want to package and send downstream. Okay? I want to make sure I do that. There are pieces of software that do this for you. They all work the same. None of them is better than any other one, right? I see customers all the time want to change from Azure DevOps to TeamCity or vice versa or something, and it's silly. All you're doing is wasting time that you're not spending building features. All these systems work. Okay? You may not like them, but they all work. All right, testing should be automated. Hamish and I could do presentations of this. We talked about this for days, probably. The keys are that you should have some known starting state for all your tests, just like I would in C# or Java or any other language. There are testing frameworks that are built to test SQL code. Most of them are based on JUnit or NUnit or XUnit, which is what application developers use, but they work in a very similar fashion. Okay, I'm a big fan of T-SQL-T, but there's plenty of other frameworks out there as well. And then the last thing I'd say is it's helpful to have a good set of test data that you can use. I think this is one of the best investments your software development team can make is get a curated set of data, right? Safe, protect PII, mask it, anonymize it, synth it, whatever you do. But having a test data set that is the same for every developer and the same for CI and QA makes it so much easier to reproduce problems and for us to talk about how our code should work. I have some customers that do this, and it's a fantastic investment. But like tests, it's an ongoing maintenance thing. If I add columns, I have to update the test data set, right? All that stuff matters. All right. So hopefully, I guess we'll see if things ran. I would have kicked off a CI process here, ran 5 minutes ago. It failed. Anybody know why it failed? Any guesses?
No internet?
This is in the cloud right now.
The demo gods hate you? No.
No, that code that I wrote was not good code. So it failed on this test that I have a table without a primary key in there. Right? When I wrote this code, and I know I have it somewhere here because I saved it. Documents, Management Studio is somewhere here. There it is. Melbourne demo. This table did not have a primary key as I wrote it. Right? Doesn't have nullability either. You can see that. Make it slightly larger. Okay. If you learn nothing else tonight, please learn that all tables should have primary keys. Laughing, but I bet you some of you have done this. Tables should have primary keys. There are reasons not to do this, but most of you don't have those reasons. Please put primary keys on. Okay. You just save yourself a lot of work. So how can I put primary keys on tables? Anybody have any guesses? Nobody wants to answer me. There's easy ways to do it. I have to not null. I need to make a constraint in there as well. By the way, let me just make sure, prove that I didn't do anything weird here. I go to my other database. It still doesn't work, does it? Nope, doesn't work. No data there. Fantastic. All right. So let's fix things, right? If I wrote C# code and I had a bug, somebody came back and said my method was incorrect, whatever, didn't have a semicolon, I would have to go back, resubmit changes. So that's what I want to do here. In this case, I should see changes to my table, and I do. In fact, I see my checkboxes. We've added a constraint there. Okay. We've got the data there finally, so let's commit that. Fantastic. Now this is just kind of tooling, doing the same thing I did manually, right? When I did all this stuff in here, where I commit, I add, I do all that stuff. I'm just doing it with tooling to make it a little bit easier. We'll push it out there. When I go out here, I should see a change. I did. We'll create a new pull request. I shouldn't approve my own pull request, but I'm going to do that because why not? And I've got all those changes. I've got the history of those changes. So if I were to come in here and look in this play, let's do it this way. Tables, change. Right, I've got this table now that I didn't write this code, right? Like my code looks different than that. I actually had 3 different statements I had to write, between this code and this code, right? That looks very different than this code. Okay? But I've captured kind of the essence of what I'm doing. I've got the history of what I've done here. I've committed stuff. You can see I've been playing around with this as well. More importantly, my CI process is kicked off and it's running right now. So part of what should happen is once somebody has committed code, we might run a private evaluation for them. But once a pull request is approved, we want to make sure that we put their code together with everybody else's code and we reevaluate it somehow. And so you can see at a high level, what I'm kind of doing over here on this side, right, is I've checked out code, right? I'm going to build it right now. That's what's running. I'm going to test it. And as a matter of fact, I have 2 test stages. Amos should be proud of that. And then I'll publish some sort of artifact here down the road. Okay. I'm going to let this run because this has been slightly slow to run. It's running tests right now, I think. But we'll let that run. I'm just going to continue on for a minute and see. Okay, we'll just assume that's going to run for now. So I put code in text. I get it to version control. I run it through CI. It's running right now and being evaluated. The next stage is I have to produce an artifact that I deploy with. Okay. And produce an artifact is a little bit weird for SQL code because, as I said, I don't get a binary back in any way that I can take and drop on another SQL Server database, right? Or Oracle database, Postgres. The database isn't really relevant here. I don't get an artifact of any sort. So what can I do? When I generate scripts, what I really need to do is capture code in some fashion that I can deploy. For some code, the code looks the same, right? So for store procedure in SQL Server, I can write creator, alter, store procedure, and that will create a new one, or it will change the one that's there. Right? In Oracle, I write creator, replace for PL SQL package or procedure, either. For tables, I can't do that. Right? For tables, the code that I write to create the table is far different from the code I use to alter the table, which is actually insane. If you think that from a language standpoint, that's an insane design decision. Because if you went to a C# developer and told them they had to write alter public static void to make new methods, they would quit and they would go find another company to work. Right? They'd find another language because it's crazy. It's just crazy. But we do that in SQL, so we have to figure out how to do this. Fundamentally, there's two ways to do this. We can use a state or comparison method, or we can use a migrational method. So I want to talk about those for a minute so that we just understand what we're saying. We just look and see if this thing is running while it's there. Still running. Yeah, it's slow. All right. So in a state method, all right, let's assume I have a dev database. Various object, doesn't really matter. This should say prod, imagine it says prod on this other side. And I've got the same object. So everything's in sync. Okay. As a developer, what I'll do is I'll just write code I need. Okay? I get a specification requirement, whatever it is. I just write random code and I apply it to my development database. So I change some percentage of objects on there. And then at some point in time, I need to run a tool. So at Redgate, we make SQL Compare. There are other tools that will do the same thing, but we'll evaluate what's the difference between these two sets of objects, right? Two databases. And that produces me a script that has the appropriate changes to make that database look like this database. Make sense? Okay. And then I run that script on production and it's fine, right?
Dev too.
Copy and pasted something a while ago. So that's how plenty of people work. It's worked for years. A lot of people do that. So in the migrations world is very similar. I've got two databases as well. I write the same code. Okay. I still apply this to my development database in some way. The thing is, as I'm writing that code, I need to track what I've done and in what order. Okay? Because chronology in databases matters for dependent objects. So I need to know what's going on in what order I've made changes. Okay? In this case, I've kind of done it numerically, but there's many ways I could be tracking changes. It's just a question of tracking all the work that I've done. Okay? And then when I want to apply that, I just run those in order again on the other side. And then everything's great. One is not better than the other one. They're just fundamentally different. Okay? For people that like this method, it's very simple for developers, right? Because I can let you all go crazy, make whatever changes you want, and then the tool will assemble the entire list of changes later, and we can figure out whether we like those changes or not. When I merge code, it's super simple because I'm really looking at two create statements and saying I'm merging them together, right? So if you've added a column and I've added a column, we just merge that together. Works pretty well in general, okay? I also can get some history because if I'm always saving off the create table statement, right, I'm always changing the same file, I can see what's going on. Challenges are, sometimes when I look at state A and state B, there's multiple paths to get there. And I might not like the way the tool picks the path, or the path may not work. Now, renames is a classic example because if I see object A and then I see object B, How do I know if they're the same object, or how do I know if they're different objects, right? Because I could have dropped A and added B, or I could have renamed A to B. Now, there's a lot of tooling that will just kind of fudge that and take a guess. But there are similar types of challenges where we do things like splits or renames, or we have to do things like maybe I have to add a not null column as null and then move data, make some changes intermediate. The tooling can't handle that in a state method. Okay, it breaks down and we have to find a way around that stuff. Okay? So a lot of times when we're making simpler changes, this works really well. When we get to complexity, it doesn't work well. Especially if you're trying to do things like make zero downtime deployments to your database, state method is really hard to do. Or if I'm trying to uncouple work, because Hamish completed work, and then I completed work, we sent it to QA, and we realized that Hamish's work wasn't right. How do we uncouple his work from my work and still deploy my work? Hard to do in the state model. The migration method, it always works. Because we know it worked on database 1, it will work on database 2. Okay? It's perfect. I can control how we make changes. I can handle any sort of problem domain I want to. It's amazing. But harder for developers. We put the burden on developers to track this work in order. Maybe more importantly, when we do merges are really hard because if we're tracking order of scripts, what if we're working independently on branches? How do I know what order to put things in? What if Hamish adds a column to the table and I add a column to the table? Whose column goes first? Because in his branch, his will go, and my branch, mine will go. We put those together. We have to arm wrestle or something, right? Do something to figure out how to do it. Other problem, well, history is hard as well because things are broken and changes, is that everything that happens in dev happens in prod, which is good for deployments, right? For risk. It's bad for DBAs. Because if Martin adds a column and he moves a bunch of data there, and then he drops the column because that was a dumb idea, and then he adds another column, he moves more data around. That's fine when I have 100 rows of data. That sucks when I have 10 million rows of data in production. It causes locking, blocking, delays, all sorts of issues. It works. It's just problematic.
I'm all right because my dev database has only got 100 records in it.
Exactly. Now, I've worked in some large Oracle and DB2 migrations where we literally pay DBAs to sit in a room like this for 50 or 60 hours running scripts because that's how we upgrade a database. It works, but it's not a great efficient use of time. It certainly isn't a zero downtime type of thing. Okay. So ultimately, these both have pros and cons. At Redgate, we try to do a little bit of a hybrid to make this a little bit smoother, but you're still struggling a little bit with state and migrations all the time and how to do things. Right? Ultimately, everything's migrations, right? When this produces a script, it's just one big migration script with everything in it. But managing work and managing change is just a hard part of software development, no matter what. So I don't want to make it seem like it's easy, and I don't want to make it seem like Redgate or anybody else makes it super easy. It's still hard. Yes, sir.
Yeah, can I ask a question? Normally, when you have change, right, the database changes are integrated and go hand in hand with the code change, right, application. Right. If you're adding a new table, like you did, right? Add this new table.
Yep.
Some application code is going to use that table, right? Whatever application.
Maybe.
But it's very rare that a table is put in isolation.
Okay.
In database.
Yep. Your question.
It goes along with.
So your question is?
Question is, the two would go hand in hand. The database is not in isolation. The DB changes you, the DBA changes.
All right. So what you're saying, let me try to summarize people online that often I will have application changes and database changes I need to coordinate together. I don't do database changes in isolation. Okay. So I would take issue with the second part of that because we can make database changes in isolation at a point in time, right? Like I may make a change to a database. I may have a management store procedure, maintenance, or archival. I may do stuff that doesn't involve an application. But you are correct. A lot of times an application does coordinate, but it doesn't have to, right? Because if I add a table, my application shouldn't break. Correct?
Yeah.
If it breaks, I think we have different problems. But at some point in time, I will deploy an application change that uses that table. Correct? probably, right? The ordering of the work and trying to match those up is always a challenge. What I would say from seeing a lot of customers, the more that I can lightly couple things together, the better off I am. So many times what we do is we do build separate pipelines for database code and application code. Right? Often the database pipeline will call the application pipeline, right? Because I add the table and then I deploy the application that reads the table. But a lot of times I may deploy the application where I don't have database changes, right? So I want to decouple that so I don't accidentally deploy something I don't want to deploy as well. So there is a challenge in coordinating work between application software and database software, which also includes ETL stuff, reporting stuff, other pieces as well. But that's a kind of a separate issue of how do I make changes to a complex system, right? Or a distributed system, because a client or a server and a database are two distributed pieces of work. Okay. So I'm not really, we could talk about that, but that's a very different discussion, a very long discussion as well.
But normally it'll be part of one branch.
No, I would say I would not put them in the same branch or in the same repository. I would keep them separate.
For example, if you were changing a store procedure to make it more efficient, there's the relevance to the application. It's still passing the same parameters, getting the same record set back. The application's not changing in any way.
Yeah.
Why would you want to do an application deployment if that's all you've done?
Yeah. So let me just go because I don't want to get too long. Having good test data is one thing. The second thing is I should always separate deployment of code from release of code to customers. Okay. Which means that I would always decouple those things, that I would deploy database changes and or application changes and feature flag toggle those things on separately. So whether I have it in one branch, one pipeline, or two or five is irrelevant. Okay. Don't think that I have to do things a certain way, that I want to do what works best for my customers.
Yeah, sure, but it seems to me if it's are integrated, they're talking to each other, they go, look, I need to do this table first, and then the code will come to.
But only in that situation. There are lots of situations where I don't need to change an application database. So tightly coupling them creates a problem, or it creates an overhead that I don't need.
Yeah, good. Yeah.
Right? So having them separate means that I have the ability to deploy one without the other.
Yeah.
Some ORMs build that tight coupling in directly.
There's lots of tooling and software that will build tight coupling in.
And there's actually people like myself who build beautiful pipelines that are triggered and cater for that. Well, we can talk about it.
Yeah. All right. So just keep an idea, right? My pipeline, my CI ran, right? Everything ran, it tested. Look, Hamish, look, I have tests. Yeah. I had 20 tests that ran in there. Fantastic. Okay, here is my integration database, right? That has errors in this code. Doesn't have errors in it. Right? So I didn't actually go over to that database and run code. It just got there.
Yes.
Okay. I'm going to actually kick off a release because this also runs slightly slow. I'm just going to kick this off, and then I'm going to talk about what this really means. So my internet is live. Come on.
There you go.
We got to refresh it a bit, huh? Try it again. Oh, there we go. Ta-da. On. What is going on there?
Like you today.
Does not like me at all today. That is crazy. I just did a release earlier and it worked. There we go. No, they deployed something in Azure DevOps. They do that regularly and they mess me up. All right. We're deploying code. How you deploy code is up to you, right? All my clients, I see it many, many different ways. The key things is that I want an automated process as much as possible. It's very consistent. Okay. Whatever types of things I have to do. Do I have to quiesce systems? Do I have to kick users off? Do I have to set things to read only? Whatever types of things I have to do, I want to have that in an automated process. As much as possible, I automate it. But for a lot of people that are trying to build automation, I still have humans involved because some things are hard to automate. You know, I may have to contact the customer service person has to let customers know in advance, right? We may have all sorts of things. So as much as possible, I try to build an automated process using a server, but I use manual steps where I need to. And I'll show you an example of one of those. We'll see one in a second. But the goal is just start automating things slowly, okay? And then improve this across time. There's no magic way to just say this is how you deploy a database, because you will have different situations in your environment that you have to account for. And even across applications, I may deploy slightly differently to different ones. So the key is there are pieces of software that know how to move bits from machine A to machine B. Okay. This could be something like calling SQL command in PowerShell or SQL Plus in Oracle in Bash. It could be using entity framework tooling. It could be using Redgate tooling. It could be any number of ways you want to do it. The key is whatever I would do manually, I want to find a way to run that programmatically. Okay. Typically, that's from the command line, but that's what I'm trying to do. Okay. I kicked off this release. Oops, where's my thing? One of these is actually running. You can see what I've actually done is I have different environments here. I actually deployed these three on my laptop, and there's one in Azure as well. But I have the same process automated for this thing to just run. And if this thing completes, there's actually an approval step in here that will ask me to approve something because it's a manual stage step. Let me let that run, and I want to talk about a couple other release things while it's going. So rollback of code. There's no real rollback in the database world, right? Because we track transactions for everything. Unlike C# where I just grab the old exe and I stick it on the server somewhere. The only way we do that in database world is doing restores, and we don't like restores, right? Restores make customers unhappy. They interrupt customers. We don't want to do that. What we can do is we can deploy reversing transactions, right? If I change the store procedure because I'm tuning it, I can go get the old code and stomp it back on top of it, right? That's an easy thing to do. That assumes I have the old code, right? It assumes I version controlled it or saved it somehow, but I can easily do that. I do have some clients that use automated tooling, and they have this code as one pipeline, because a lot of these toolings, I can just pick the previous version and it will send that previous version back to the server. Right? That's how C# developers often do it, or web developers. They just pick the previous version and say, now deploy this old version. If you've got create or replace code or create or alter code, you can do that. Can't do that with tables. Okay? Because if I've changed the table, I have to run a reversing transaction to change the table. But how do I do that? Right? What do I do? If I add a column, what do I do? Do I drop a column? When do I roll back though? Because I find for a lot of clients, it's not that we deployed code now, right, 2 minutes ago, and then we find a problem. Typically, we deploy code now, and then Friday morning, somebody calls us up and go, I think that change was bad. And we often have tens of hours when customers have been making changes that we have to decide, what do we do with those changes? How do we recover? That's hard to do. Okay? So what I normally say is you need custom code here, because you have to decide, what do I do with data changes? How do I handle undoing a table change? If I had an index, easy to drop an index, right? But if I've added a column, what if I've changed a data type? What if I've done a split of columns? Those are hard things to undo. Okay. So what I usually tell people is that anytime you touch a table that potentially causes an RGE, you need to pre-write your scripts. Does anybody have a guess what an RGE is? So my colleague Grant says an RGE in America is a resume generating event. You break something that's going to cost you your job.
What we call it DCM. Don't come
Here we call it a CV generating event.
Don't come under.
What you should do is think about, how would I fix this if it's 10 hours after I deployed this change? Write that script. Then I deploy to QA, I test it, then I deploy my rollback to QA and make sure I actually can fix what I changed. which doesn't mean I just undo stuff. You need to make sure that I actually get back to the state I'm expecting, because it's easy to conflate those two things and they're not the same thing, especially if I move data in any way. Right, so you want to be really careful. However, the thing I say is I'm a big fan of dark deploying code, meaning I should be able to deploy additive changes to the database without breaking the application in any way. So if I add a column, it should not break your application. Okay. Now, it requires some coordination with app developers. We have to write good code, but there are ways to do this so that I can make a change, see what the effects are. Then later on, we deploy the app code to take advantage of it and start using it and everything else. Okay. That way, if I have problems, usually I flip a feature flag in the application and we figure out what went wrong.
Like that.
Exactly. Okay. The best example I have, Facebook did this with Facebook Messenger. I don't know for any old people like me use Facebook. When they built Facebook Messenger, real-time messaging service, right? It uses a database to track stuff. They had about 600 million customers. Anybody here have 600 million customers? Anybody want to build an application for 600 million customers, right? That's a recipe to never go home and never take vacations, right? But they deployed that thing and they were 100% positive to work from the day because they made a bunch of changes in the background across months so that when they turned it live, they knew it would work. And I'm a big fan of doing that. That's why I say separate deployment from release. Even if it's 10 minutes, give me 10 minutes to make sure I haven't broken anything horrifically before we deploy the application and turn stuff on. Makes a huge difference to what I do. So I deploy things without anybody knowing that they went through, right? So it requires, so if I deploy a new column of table and I write insert table, select 1, 2, 3 or values 1, 2, 3, that may or may not still work in an application, right? But if I have insert table column list 1, 2, 3, and I add fourth column, that will still work, right? Maybe I have defaults or not, right? Like I have ways around that, but I have to write good code that allows me to dark deploy things and making changes that don't cause problems. Okay? I can add new parameters, store procedures if they're optional, if I have default values. There's various things I can do to avoid breaking applications. The other thing is that there are some data or some things you deploy you can't ever test. So things, often email servers, messaging queues, cryptographic objects, certain things, A, you don't want to deploy them to pre-prod environments, but B, I can never really test them. Even the any of the C# developers that have your app.deploy.dev and app.deploy.prod, right? You have those things. You know that app.deploy.prod is never tested until we get to prod. We are assuming that you ladies and gentlemen can type correctly, which is sometimes a big assumption. I don't have a good solution for this. The best thing I've seen is have two people whose job depends on it type the data into production and then use tokens or replacement or evaluation in real time so that you're always getting the value from the environment. Okay? You can test token replacement into QA and stuff, right? If I have an email server or whatever, but the time you actually type that data for the first time is the time you have to make sure it's correct, right? And that's the best thing I've seen. I've never seen a great solution. People break this stuff all the time. Like all the time, people mess this up. All right. Before I summarize, let me see, did my thing complete? So one completed. I have an approval stage here, which is it's stopped the deployment here until I hit approve, and then it'll actually run it. But in my code, let's see if I can do this one-handed. This and this. Look at this image. I can do coding one-handed. I got that table and that data into QA without actually running it anywhere. Right? And it'll be in staging in a moment. So I'll mess up again. So my hands aren't that. Right. It's not there yet, but as soon as this thing runs, it'll actually be there. But I won't wait for that. All right. So the big thing I think I want you to understand, right, that DevOps has really worked well for software for the last 10 years. Right? Ever since I think maybe 2010, when app stores became really popular with the iPhone 3 and iPhone 4, the quality of software has gotten really good. really, really good. A lot of that is because software developers do a lot of unit testing. They do a lot of evaluation. They practice deploying stuff over and over again. They're following these principles in DevOps very well. When I do that with a database, then life becomes much better because then I start to coordinate everything together. The developers are all working in a similar fashion across these platforms. And I'm taking advantage of all the knowledge my software developers have to apply that to database code. Not perfect, database code is different, but as much as possible, we want to keep it like software. And then last thing, these two things have helped me in my career really well is that stuff that works really well, I do more and more. Right? I get other people to do it. We get other teams to do it. And stuff that doesn't work well, I stop doing it. I have no shortage of customers that do insane, stupid things and they keep doing them because that's the way they've always done them, because they're used to doing them that way. That's not helping you get better at building software. You have to grow and change and learn, adapt to what works well. When you see dumb stuff, find a way around it, stop doing it. That makes a huge difference. All right, that's all I have. Other questions? Any questions? Anybody online?
If you're online, check your questions in chat or come off mute.
Anybody here if you have questions? I know it's going a little quick, getting stuff done, but all right, if you have questions, I mean, please feel free to reach out to me later. I'll post the deck. I don't know if it's that useful, but
I'll throw one in. Going back, you made I know you bit around the state against migrations.
mhm.
The objects like procedures, functions, etc. Just grab the latest, run it.
Yep.
How do you find that if the database needs to be recreated to a particular version? Doesn't that make it harder to go, I want it to be as of such and such a date?
Why would you do that, Martin? So Martin's saying, what if I have to create a version of the database that's at a particular version? Right? Like part of the reason I do version control, right, is because I have all the versions of code at different points in time. So based on commits or dates, I can figure out where the database is. But really, as a practical DBA, I would just restore a copy of the database from that. Like, honestly, if you want to know how I do things, I try to just keep things as simple as possible. I would just restore the database, what you expecting. And I might then, branch code and match that up and try to go, what am I trying to accomplish there? But
my example is coming in and trying to work back something that has broken, and fix it and get things. I can say, well, looking at the migration scripts, this gets me the stage is what things look like, but I trying to then sync that up with the rest of the database objects.
So for migration scripts, right, like I could just say, easy way is put them all in a folder, right, and pick a section of them, delete them, and go, I'm trying to get to this point in time with my migration scripts. With my state-based thing, that's where I would go to history. I would check out a commit in Git, which would give me the view of the code at that point in time. And then I would have all those files in the state-based world to run against the database, say, here's the version of store procedure, here's the version of table, all that stuff would match up. That's a great reason to have version control, is because if I have to go back in time, because I'm sure for you, right? Like I have 20 clients, one of them's on version 5 and everybody else on version 7, and I have to fix something for the version 5 person. I need to go back to version 5 constantly to do that. I would probably hold a branch at version 5. That would be, here's where we do that, right? That's what SQL Server does, right? So SQL Server, right, they hold RTM plus GDR branch, and then they hold the latest CU branch, right? So when we have a security release, they build a fix and they merge to RTM branch and they merge to latest CU, and then those two packages come out. So that's exactly how they do it, because they need a version of code at that point in time. Same thing for the database. You just hold two branches open.
I don't mind the approach of just
I know you're just trying to be difficult. I get it.
I just put the migration in for the change on the store procedure as well. Just put the alter in there, or create an alter into.
Yeah, I mean, a lot of this stuff is just good habits, right? Like, you should never write create procedure. Like, nobody should ever do that. Every piece of code should always be create or alter procedure, or create or replace procedure, right? Depending on your syntax.
Right, except when you're working with really, really old versions of SQL Server. Yeah,
Can't help you there, man. I'm in the modern world,
I wish my customers all were.
Yeah, I'm with you, right? Like not being able to, like in the old days when we couldn't do create or replace, that was a different type of broken SQL language, right? Like that's crazy that you couldn't do that.
Mm.
You know, so then you have to guard, right? You're right.
Yeah,
If not exist, create procedure,
So
name.
everyone has a stub of just create procedure as an empty procedure.
Yeah. And that's one way to do it too. But it's a lot of this is just learning to be better. Right. A lot of this is common sense stuff. Like if I told you, be better at your job or you're fired tomorrow, a lot of you would just go, yeah, I can write create or replace. I can do stuff easier. But you have to just make a little bit of effort. Then it becomes a habit. Testing is not hard, but it's hard to start.
Yes.
But once you do it for a month, it's not that hard to do.
Yeah.
Right? Like once you learn the skill, it becomes a habit. Right? For most of my career, nobody tested software. Right? So who is over 40 that remembers a blue screen of death on your laptop or server?
Yes.
When's the last time it happened to you?
Last week.
To accept. For most of it, it doesn't happen, right? Like it just doesn't happen.
It's rare.
Right? When's the last time your phone crashed?
Several
It
phones ago.
doesn't crash, but it stops working.
Actually,
It's like
freeze.
I cannot cut phone calls. Just
It does happen, but it's not very often.
I found that it doesn't work well if you put it in the washing machine.
If you're IP86, it probably does, right? Can't get too hot. Can't get hot. But the quality of these things has driven a lot of software, and it's because developers now know how to write unit tests. Like I don't know anybody that can get hired as a developer if you won't write a unit test. I mean, most companies like I'm not even gonna talk about it, right? Like if you go to an interview, and go, I don't know how to write a next unit test, and like, I've got 50 other people that know how to do that stuff. I don't need to hire you, right? The same thing in the database world. Like just being a little bit better at what we do makes a huge difference. Not today, but across time, quality of your stuff goes way up, way up.
A quick request before we finish up. Can we get a selfie together, Steve-O?
Yeah, we can. All right,
My kids asked.
let's see. Did this work? It worked. Look, over an FC, my demo system now. And I'm sure it's going to production now too, but
It is.
you know, that's what it should be like. It's actually going to Azure right now. Right? It should be able to that. I write that code and all I'm doing is saying, go, approve. That's all it should be happening. You know, and this frees up time for DBAs to do stuff like performance tuning, right? It's not like we have a shortage of work,
Yeah.
right? So if I stop having to connect to these systems, we can just press buttons. We get so much more work done. How many of you have less work this year than last year? Right? So when you waste time doing stuff like, you know, connecting machines and running code that the computer could do for you, you're just wasting time. You have plenty of other work to do. Nobody's getting fired because you automate stuff. Right? You're getting more stuff done. You're making clients happy. Just try to make clients happy. Right? That's really the goal here. So, all right. If you have other questions, please feel free to reach out. I am here. Hamish is at Morph IT and NZ.
I am.
Yeah. And thank you very much for having us come.
Yeah.
I really appreciate it.
Better.
I work for a really harsh boss. He wonders what I do away on this.
All right.
Send that through and I'll put it on our group as well.
Oh, yeah. I'll send it over to you.
Thanks.
All right. That's it.
Cool.
Pizza still.
Thank you. Gentlemen, thank you for traveling internationally to come and speak with us.
Pleasure.
Very awesome.
Pleasure. Thank you for inviting us.
Yeah, absolutely.
Time.
Thank you to everyone who attended. Thank you to everyone who's still online. Like we said, if you've got questions, reach out. Otherwise, grab some pizza and we'll let you know what the next month's one is when we get it. There's